Hi, Calc with Apps. We're working from the blue packet, Limits and Continuity, our first unit in marking period 2. I'm working from page 3 in that packet, and your homework tonight is page 5 and 6, all problems. So I'll start as always by reading the mathematical definition of limit, and then we'll discuss what it means. If f of x, if a function becomes arbitrarily close to a unique number L, as x approaches c from either side, the limit of f of x as x approaches c is L. So, as always, let's see what this means mathematically. So, I've got a function. I'm approaching c. Our c is our x value, our value that we're approaching on the x-axis. And it says, as we're approaching c from either side. So the key words here are approaching and either side. So I'm coming from the left, and I'm getting closer and closer to our x value c. I'm coming from the right, and I am getting closer and closer to our x value c. And the question is, when I do that, am I approaching L, which is one specific y value? If I am approaching the same y value from the left and from the right, then we can say a limit exists at our x value. In this case, in our example, it's c. So back to our definition. As the function gets close to one specific y value, that's our L. And as we're approaching, remember, we're not reaching, we're walking towards our c value, our x value. We are walking towards there. We only have a limit if we approach the same, if we get closer and closer to the same y value from the left and right. So the way we write the definition of limit in general is limit as x approaches whatever number we're talking about. So as x approaches c of f of x equals our one specific, the same y value. So one-sided limit means we have a limit from the left and a limit from the right, and each of them has their own notation. From the left, we have the limit as x approaches c from the left. Notice that the minus sign is after the value. And then we say of our function. So the minus sign, and you can see it down here in 1a, the minus sign means as we approach from the left. On the right, you can imagine the limit as x approaches c from the right of our function. The plus sign again is after whatever that x value is that we're getting closer and closer to. So let's see this definition in practice. Number 1, the limit as x approaches 0 from the left, 0 with the minus sign afterwards means we are approaching our function from the left of our function. So the graph you're seeing is the absolute value of 2x over x. So as we are approaching from the left, we are getting closer and closer to the x value 0. That limit notation is asking us, what is that y value that we are getting closer and closer to? And if you look before I drew all over it, you can see that that y value is -2. Then, our next one, 1b, asks the limit of x as we approach 0 from the right of our function absolute value of 2x over x. So here we are, walking, 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 getting closer and closer to x equals 0. What is this y value that we are getting closer and closer to? That y value is 2. Now, it says we have to approach the same y value from both the left and the right in our definition. On the left, we're approaching -2. On the right, we're approaching +2. So, for our overall limit definition of this function at the value or approaching the value 0 from either side, we say the limit does not exist because -2 and 2 are not the same y value. So if we are talking about the existence of a limit at a specific x value, or as we approach a specific x value, we say in our math definition, if f is a function and c, the x value we're approaching, and L are real numbers, so we find them on our x-axis and y-axis respectively, then our limit of x as it approaches c of our function f of x equals L, means equals that one specific y value, if and only if both the right and the left limits, the right and left limit or specific y value is equal to that same y value. So now let's see it in practice in another example. We're on number 2. It says find the limit of f of x as x approaches 1. So notice we have a piecewise function. It has 3 pieces. It has a line when we're talking about x values that are less than 1. So we've got the line right here. And then we've got our quadratic function, which is when x is greater than 1. You can see that we've got part of our quadratic. And then at the value. So remember, when we're talking about limits, we are approaching. But when we are at, when we've actually reached the value of 1, then our piecewise function spits out the y value 5. You can see that. This is an open circle, and you can see here from our examples up here, when we were approaching 0 from both sides, we had open circles. In our example up here, we were approaching an open circle, but down here for the first time, when we actually get to the x value of 1, then our function spits out the y value of 5. So of course that's going to come into our evaluation of our limit. So let's start with the 2a, where it says the limit of our piecewise function. Now notice, as we're approaching from the left, it's the linear function. So we're going down, 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 we're walking down, 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 and it asks what's happening as we get closer and closer to x equals 1. Well, the y value that we're approaching is going to be 3. It's not going to be this jump up here because our goal is to go along the function that exists. We're walking. We're not walking in space. We're walking on that function, seeing where we get closer and closer to in terms of a y value. And now we are going from the right. We're walking up our function, up our function, up our function. And now as we get closer and closer to the x value 1, again, the y value we're approaching is 3. So C asks, just like it asked in one above, does a limit exist as x approaches 1? Well, yes it does. Is our limit for from the left the same as the limit from the right? Yes, they are. They're both 3. So since they're both 3, we can say the limit as f of x, the limit of x as x approaches 1 of our whole function, of our whole piecewise function, as we only approach, now we're only talking as we approach 1, is 3. Now you can't see it down here, but you should see it clear in your packet. D asks, well, what happens if I actually plug 1 into my piecewise function? So I'm no longer approaching. I am at x equals 1. Well, we can see it 2 different ways. We can go up to the piecewise function and say, well, it says right here, if I actually plug x into my function, it's going to spit out the y value 5. If I look on my graph, as I look at exactly at x equals 1, I'm looking for a closed dot. Well, the closed dot is not what I was approaching from the left and right. The closed dot is here. So it's not at y equals 3. It's at y equals 5. So the limit, as we approach a specific x value, and evaluating, meaning actually plugging that x value into my function, are often not the same.